Algebra 2, Common Core, Parabola, Focus, and Directrix. Prior to this, you've learned about parabolas for probably a couple of years. The quadratics, the quadratic equation, you've talked about the roots, the vertex, the axis of symmetry, and you've probably graphed parabolas and maybe even solved some parabola linear systems and things like that. So you've worked with parabolas for a while, but you've probably never actually learned exactly what they are, where they come from, or what the definition of a parabola is. So like you know that for like a line, for example, a line is a set of points that have the same slope and they are on a straight line. Well, a parabola is something like that too. It's a collection of points, but it's more than that. But first, let me give you the definitions that you already know. The axis of symmetry, that's a vertical line. Well, it's vertical if your parabola is like this. Parabola could be on the side, but it's a line passing through the vertex in which the parabola is symmetric. So in purple here, I have the parabola, and the y-axis for this case is the axis of symmetry. And if I were to fold over the y-axis, the parabola would reflect or fold onto itself. So it's symmetrical across that. It's a mirror image with the axis of symmetry, in this case the y-axis acting as the mirror. The vertex is the maximum or minimum point on a parabola. So in this case, a parabola looks kind of like a smiley face. We would have a minimum vertex down here. If we have a frowny face parabola, which comes when our lead coefficient is negative, then we'd have a maximum. So we could either have a minimum or a maximum. We will not have both on a parabola. You only have one. Now, two things you've probably never discussed before in math: focus and directrix. Focus is a specific point on the axis of symmetry. And for this example, our focus here is 0, 2. It's on the axis of symmetry, but it's not any point on the axis of symmetry. It's a specific point. There's only one focus for every parabola. And the directrix is a specific line perpendicular to the axis of symmetry. And it's not just any line, it's a specific line. Every parabola has a directrix. And we usually don't graph them, but they're there, the focus and the directrix. And together, they are what makes a parabola, because a parabola is a set of all the points that are equidistant from the focus and the directrix. So all the points that are the same distance from this point and this line is a parabola. Like we look here, the vertex is the same distance to the focus and the directrix. If we take another point here, and if we were to take out like a ruler, we can measure the distance from the focus and the distance to the directrix is the same. Another point, like this point I have up here, xy. If I were to, let me use the line tool for more precise here, but I'll make it dotted. So this distance between the point and the focus, that is the same distance between that point on the graph and the directrix. Now the point to the directrix is always just straight down. So that's always a perpendicular, and so that's usually just a vertical line when our parabola is a normal y equals parabola. But the distance between the point and the focus, that's slanted. We would need like Pythagorean theorem or the distance formula to get that distance. But these two distances are congruent. Like hypothetically, I don't know what this distance is, but let's say it's 12. Well, this distance would be 12 also. And so that's what a parabola is. It's all the points that are the same distance to a point and a line. And obviously the point in the middle, but then as we go further to the side, like a point over here wouldn't make sense because it's closer to the directrix than it is the focus. And the point over here, it's closer here than it is here. So that's why it curves out, because it has to be the same distance to both of these things. And so that's what forms the shape of the curve for a parabola. These are all the points that are the same distance to the focus and the directrix. So a focus and directrix are really what creates the parabola you've known for a while. So given a focus and directrix, draw a parabola. Well, we just want to plot a couple of points that we know are equidistant between these things. The easiest is the vertex, is right in the middle between them. And then there's really only two others. Sometimes you could find more, but the two others, the easiest way to think about them is what's the distance between the focus and directrix right now. Right now they're 2 boxes away, so 2 units away. Whatever this distance is, go that distance to the right of the focus and to the left of the focus. And those are your other 2 points, because this is 2 to the right, and it's also 2 away from the directrix. 2 from the focus, 2 from the directrix. You can almost kind of picture it as a square. So figure out the distance between the focus and the directrix and just do that to both sides, and those points will work for equidistant. And the vertex in the middle is fine. So then once you have these three, you can just kind of draw your curve. Sloppy, but that'll do. So don't worry about finding other points other than those three because it gets tricky. One more question I want to do here. All right, this question, we're given a focus of 1, 0, a directrix of y equals -2, and a point on the parabola. I don't have its x value, but I do have its y value 3. I want to find the x value. So I want to find the x value of a point. It's got to be equidistant to these. Find the x value for the point in which x3 is equidistant from 1, 0, and the line y equals -2. For these problems and the next video, which is also about this, but it's about finding the equation of the parabola given focus and directrix, we always want to start by writing down the three things you have. The points we're working with is x comma 3, and that's just a point on the parabola. So I'm going to call it P. P is the point on the parabola. F is the focus you're equidistant from, the point that we're equidistant from this and this. These are your focus and directrix. So the focus is 1, 0, and the directrix is y equals -2. So write that too. D equals, or D, y equals -2. So always state what's the point you're working with, what's the focus, what's the directrix. And the way we solve this is use the fact that it has to be equidistant. So the distance between the point and the directrix has to be equidistant to the distance between the point and the focus. So I have to figure out what's the distance between these first and then match that to the distance between these. We always start with the distance between the point and the directrix because, as I said earlier, that's just a straight vertical line. It's a pretty sloppy line there, but you get the point. And so that distance is usually much easier to find because we can just think about, since it's a vertical line, there's no change in x. So all we need to consider is the change in y. So the y's, I'm just looking at the y values, and I have the y value for this point 3, and I have the y value for the directrix 2. What's the distance between 3 and -2? Well, if you think about it on the number line, the distance between 3 and -2 is 5. And so that is the answer here, it's 5. But another way to think about that is you could always do the point's y value minus the directrix y value. And the point's y value is 3 minus the directrix y value, -2. And when we minus a negative, 3 minus -2 is 5. So start by subtracting the y values of the point and the directrix to find the distance between the point and the directrix. Then, the distance between the point and the focus, this distance has to be 5. And so this distance is also 5. And I can use the knowledge that I know this distance is 5 to figure out a missing part of the coordinate. I can figure out this missing x value. Because what I could do is the distance formula between these. Remember the distance formula from geometry? It's coming back. So we can subtract the x values squared plus subtract the y values squared under a giant square root. And so I'm going to do this between the point and the focus. I don't have to do that between the point and the directrix because it's vertical. But this is slanted, so I need to do that. But I'm not going to write d equals because I know what the distance is. The distance has to equal 5. That's why we get this number first, because I set that number equal to the distance formula for the point and the focus. Subtract the x's. That's going to be x minus 1 squared plus subtract the y's, 3 minus 0 squared. Now, we learned this in the previous chapter that I could get rid of this giant square root here by simply squaring both sides, and that'll make the problem a little bit easier to work with. So 25 equals x minus 1 squared plus 3 minus 0 squared. So get rid of that square root by squaring both sides. All right, now I want to simplify what I can in here. 25, I'm going to leave as 25 now. This right here is a binomial squared, something we see a lot in this course. It's x squared minus 2x plus 1. Remember, it's times itself. And what do we have over here? 3 minus 0 is just 3, and 3 squared is 9. Well, now at this point, I want to set this equal to 0 and see what I'm looking at. So 0 equals, if I minus 25 over, I got x squared minus 2x. These together are 10, and then I minus 25. 10 minus 25 is negative 15. And at this point, for an Algebra 2 student, this should be easy. This is a basic factoring problem. It's going to be x minus 5 and x plus 3. And so then we set them both equal to 0. We get x equals 5 and x equals negative 3. So you actually get two answers, x equals 5 and x equals negative 3. And that kind of makes sense. The one over here is probably 5. But for every point other than the vertex, there is a symmetrical point over here. And so this one's probably negative 3, 3, where this one is 5, 3. Because I know the y values are the same because it's symmetrical. So that's what we have to do, is use the distance between the point and the directrix, py minus dy, and use that distance equal to the distance formula between the point and the focus. Some algebra, square both sides, binomial squared, set equal to 0, some basic factoring. It's a little bit of work here, but it can be a challenging problem. But if you follow this procedure, it's really not too bad. More to come.